Hello again, Psych 370 students, and welcome to one last video lecture for week 10, which is going to focus on a phenomenon called learned helplessness. So, as I'm sure you remember, we recently spent some time on avoidance, right? Which is a form of negative reinforcement because it involves learning to perform these behaviors that allow you to avoid unpleasant consequences like electric shocks from occurring. We covered avoidance learning during week 8, if you feel like you need a refresher on it. However, as our last topic for this week, we need to consider situations where the person or the animal doesn't actually have any control over whether aversive things like that happen. Situations where there is nothing the person or the animal can do to stop or prevent an aversive stimulus from occurring. And guys, there's good evidence to suggest that situations like those can have some very unfortunate long term effects. Not only can they impair the individual's ability to learn to escape from or avoid aversive consequences in the future, but they can also be detrimental to that individual's well being. So, we refer to this phenomenon as learned helplessness because the animal basically learns that it's helpless. It learns that it's powerless to do anything about these unpleasant circumstances that it finds itself in. Now, the pioneering research on learned helplessness was conducted by this guy, a psychologist named Martin Seligman, and his colleagues, and they focused their initial studies on the effects of inescapable shocks in dogs. So, for example, in one of the earliest experiments on learned helplessness, they strapped these dogs into harnesses and then exposed them to a series of shocks. Now, for the dogs in one group, the shocks were escapable. So, those dogs could end the shocks by pressing a button. But for the dogs in another group, pressing that button didn't do anything. So, for them, their shocks only ended when the dogs in the other group successfully terminated their shocks. So, guys, the term for this kind of setup in an experiment is yoking. Okay. We'd say that each dog in this second group was yoked to a particular dog in the first group. And the idea there is a yoke is a device that's used to link two animals together. Okay. Like these two oxen. This wooden thing that's connecting them is called a yoke. But in experiments, we use the term yoke to refer to a link between two research subjects, meaning that when one of those animals does something, it affects the other animal too. So again, each dog in this inescapable shot group was yoked to a particular dog in the escapable shot group. And that's an important aspect of the design of this experiment because it ensured that the dogs in each of those groups got exposed to an equal amount of shock. When one dog's shock ended, the other dog's shock ended too. But again, whereas the dogs in the escapable group could press a button to stop the shock, the dogs in the inescapable group had no control over when their shocks ended. So they were at the mercy of the dogs they were yoked to, basically. Nothing they did themselves would stop these shocks. They'd only stop when the other dog in the pair made that escape response. Okay? And this experiment also involved a third group, a control group, where those dogs would get strapped into the harnesses, just like the other two groups, but they never received any shocks. So that was the first phase of the experiment. We've got these three groups of dogs. One of them gets exposed to escapable shocks, one gets exposed to inescapable shocks, and the third group is a control group that doesn't get exposed to any shocks. The next phase of the experiment took place 24 hours later, and it involved 10 trials of that standard shuttle box procedure that we covered last week. So each dog would be placed on one side of the shuttle box. It would get a warning signal, which in this case was darkness. The lights in the shuttle box would be turned off. That was the warning signal for these dogs. And then 10 seconds after that light went off, a shock would be delivered through an electrified grid in the floor. And the animal would keep getting shocked for up to 60 seconds unless it moved to the other side of the shuttle box. So, in this second phase of the experiment, the shock was escapable for all of the dogs. They could all escape from the shock by crossing over to the other side of the shuttle box. And here are the results of that experiment, presented a few different ways. So, the take home message here is that the dogs who in the first phase had received escapable shocks and the dogs in the control group who didn't get shocked at all in that first phase, both of those groups of dogs did learn to escape from the shocks that they received in the shuttle box. They did acquire that escape response in that second phase of the experiment. Not only that, but on the later trials in the shuttle box, they actually learned to respond to the warning signal, the darkness, so that they wound up avoiding the shocks altogether. However, the dogs that were first exposed to the inescapable shocks during phase one, they showed a marked impairment in their abilities to learn these escape and avoidance responses. So the dogs in that group failed to escape the shock on average over 7 times out of the 10 shuttlebox trials, meaning that during most of those trials, they just sat in the shuttle box and endured the shock for the entire 60 seconds. So, even though they were now in a situation where there was something they could do to terminate or even prevent these shocks, they didn't acquire that response. And so Seligman concluded that during phase one, during those previous experiences with the inescapable shocks, these dogs had picked up on the fact that there was no contingency between what they did and whether or not they got shocked. So, in other words, they had learned that they were helpless, right? They had learned during that first phase that their efforts were futile, that their behavior had no effect on whether or not this aversive, unpleasant thing kept happening to them. And furthermore, that learning generalized from one situation, the harnesses that they were in during phase one, to a new situation, the shuttle box that they were in during phase two. And guys, that's another important aspect of this learned helplessness phenomenon. It generalizes. Okay. So learned helplessness isn't necessarily specific to one setting or one situation. It's more general than that. It's like this generalized expectation that the person or animal develops that bad things are equally likely to happen to them, regardless of what they do to try to stop them or prevent them. So, in new situations where their behavior may actually be effective in stopping or preventing bad things from happening, they don't acquire the necessary response because they've learned that they're helpless. And so, as a result, they wind up experiencing these aversive events that they didn't have to. They wind up having these aversive experiences that they could have escaped from or avoided. Okay, so that's the classic research on learned helplessness. It was originally demonstrated in dogs, but it's also been demonstrated in humans. Although to study it in humans, researchers obviously have to use less aversive stimuli than electric shocks. Typically, what they use instead are these loud, unpleasant noises. For example, in a study that was very similar to Seligman's original research with the dogs, college students were first seated in front of a small box with a push button on it, and they were told, hey, when this noise comes on, there is something you can do to stop it. That's what they were told. In actuality, though, only the students in one group could turn off the noise by pressing the button. For the students in the other group, pressing the button didn't do anything. And as in Seligman's research, there was also a third group of students in this experiment that never heard any noises during that first phase of the experiment. Next, all of the participants were escorted to another room that had a different apparatus in it. It was a box with a knob on the top that could clearly slide from one side to the other side. So it was basically a human version of a shuttle box. Okay. And they were again told that there was something they could do to stop the noise, and then they got these signaled avoidance trials, much like Seligman's dogs had. A red light came on, and 5 seconds later, the noise blast occurred. So the participants could escape the noise if they moved the knob after it began, or they could avoid it altogether if they slid the knob when they saw the red light. So the red light was the warning signal. Right? Now, here is a graph showing the results of that study. There were 18 trials, so each data point is actually representing a block of 3 trials, and we're looking at response latency, right? In other words, we're looking at how long after the red light came on did the participant slide the knob on the top of the box. And as you can see, the ones who couldn't stop the noise before, during the first phase, showed impaired learning of this new response. So they didn't respond anywhere nearly as quickly as the other groups on this new task where they could do something about the aversive noise. In fact, much like Seligman's dogs, the participants in that inescapable group not only failed to acquire an avoidance response, they also failed to make an escape response on over half the trials. So, results like these suggest that uncontrollably aversive experiences can have effects on humans that closely parallel the detrimental effects that they can have on animals. So, in other words, even though learned helplessness was first observed in dogs, it isn't exclusive to dogs. Humans, too, can learn to be helpless. So, learned helplessness is an important phenomenon and it gets a ton of attention in research. And, guys, a big reason for that research focus on learned helplessness is that many psychologists have recognized a connection between it and depression. And there are several important similarities between them. So, for example, like learned helplessness, depression can also result from an uncontrollable, unpleasant event, right? Like, say, the loss of a loved one. There's also evidence that genetic predispositions can affect how vulnerable a person or an animal is to developing learned helplessness, just like there is for their vulnerability to depression. So, these two things seem to have somewhat similar causes. They also involve similar symptoms like reduced motor activity, loss of motivation, changes in sleeping and eating behavior. We see those things in depression, and we also see them in learned helplessness. And they often respond to similar forms of treatment too. So, for example, just like an antidepressant drug can help to alleviate a person's depression, it can also help an animal overcome its learned helplessness. So an animal is more likely to recover from learned helplessness and acquire new escape and avoidance responses if it receives an antidepressant than it is if it receives a placebo. So all of that is compelling enough, but maybe the best evidence for a link between learned helplessness and depression is that in experiments, depressed individuals who haven't gone through the learned helplessness procedure behave very similarly to non depressed people who have gone through that procedure. So, for example, in one study, David Klein and Martin Seligman used four groups of human participants. Okay. One group consisted of individuals who had been classified as depressed, and the other three consisted of non depressed individuals. Now, the depressed group and one of the non depressed groups had the same initial experience. They weren't exposed to any aversive noises during the first phase, but the other two groups of non depressed people were exposed to aversive noises that they either could or could not escape from. So, in this Klein and Seligman study, the three non depressed groups made up what you'd find in a typical learned helplessness experiment with an escapable group, an inescapable group, and a control group. And then we basically got a second control group here that was made up entirely of depressed individuals. And as you can see in this graph, the depressed participants and the inescapable noise participants performed very similarly later when they were both exposed to an aversive noise that they could escape from. So their escape latencies were very similar to each other, and they were both much greater. It took both of these groups significantly longer to escape from the noise than it did these other participants who weren't depressed and who didn't go through the learned helplessness procedure with the inescapable noises during the first phase. Now, of course, this isn't to say that that learned helplessness procedure produced clinical depression in otherwise healthy people, but it does seem to have produced an expectation that these aversive experiences, these noises, were uncontrollable. And so, guys, the idea is that depression results from experiences that have produced an even more general, even more widespread version of that helpless expectation. And so that's something that the depressed people in this study would have brought with them to the laboratory, resulting in their similar performance. Okay, so I hope that makes sense. Please let me know if you have any questions about that study. But now I want to finish up on learned helplessness by talking about some ways to reverse it and prevent it. So, like I told you earlier, there are some interesting connections between techniques that are effective in alleviating learned helplessness and those that are used to treat depression. And I mentioned drugs earlier. Antidepressants are obviously, for the most part, effective in the treatment of depression, and it's been found that they can help reverse learned helplessness too. But on the non pharmacological side of things, Seligman also found pretty early on in his research that one way to get a dog to overcome its learned helplessness was to physically drag the dog from the shock side of the shuttle box to the no shock side. And so, what he did there was he basically forced the animal to be exposed to the fact that it was possible to escape from these shocks. He essentially showed the dog what it had to do to terminate those shocks. And after enough of that, the dogs eventually began performing the escape and avoidance responses on their own. So, like I said, it was an effective way to get these dogs to overcome their learned helplessness. And, guys, that strategy has interesting similarities to cognitive behavioral therapy for depression, where clients are often required to practice these healthier, more positive ways of thinking and behaving. So, for example, a therapist might tell a client something like, okay, before we meet again, I want you to look 10 people in the eye as you pass them in the hallway. Or at the end of the day, I want you to make a list of 5 things you did that day that led to something good happening, no matter how trivial it might have seemed. So, that might be like a homework assignment that a therapist could give to their client. So, look, it's not like they're dragging the client by the leash to go do these things, right? But the idea is very similar. I mean, if you're the therapist, you're basically trying to expose your client to the reinforcing effects of their behavior, right? You're trying to get them to realize that they can actually control the pleasant and unpleasant things in their lives. And so the goal is to eradicate any learned helplessness that they may have acquired, right? You're trying to eliminate this belief that lots of depressed people tend to have about their efforts being pointless and in vain. So, Seligman's research suggests a way that learned helplessness might be combated after it's already set in. But his findings have also suggested a way that you might be able to prevent learned helplessness from developing in the first place. So, for example, in one of his studies, one group of dogs was first given 10 shuttlebox trials where they could escape from shocks before they were exposed to inescapable shocks while they were strapped into their harnesses. So, these dogs went through the same basic procedure that the learned helplessness dogs did in that first experiment that I told you about, except they got this extra phase first with escapable shocks. And what Seligman found when he put those dogs back into the shuttle box later, after they'd gotten those inescapable shocks, was that they did make the response. So they didn't just sit there and accept the shocks like a helpless dog would. Instead, they learned to escape from and eventually to avoid the shocks. So, their previous experience with the escapable shocks seemed to have made them more resilient against the effects of the inescapable ones. It made them less likely to develop learned helplessness as a result of those inescapable shocks. Now, Seligman refers to this phenomenon as immunization, okay? And it's been observed in people too. So, guys, what all of this suggests is that kind of like a flu vaccine can immunize you against the real thing, a history of successfully overcoming adversity, a history of previous experiences where someone was able to do something to stop or prevent bad stuff from happening might also be able to protect that person from becoming depressed and feeling helpless in the future when they're confronted with more serious difficulties. So, in other words, previous experience with success, past exposure to a manageable amount of aversive circumstances may be able to teach people not to give up when they're faced with even greater challenges. So, those prior experiences can teach people not to perceive their current challenges as insurmountable. That's one of the more interesting and more useful findings that this research on learned helplessness has led to. So, for example, one way that this immunization idea has been applied in the classroom is by encouraging teachers to start off with tasks, especially in a challenging subject like math, that most students are likely to have success with. So start them off with something that they're likely to be able to do, right? And that way, later, those students will be less susceptible to learned helplessness when you get to the more difficult stuff. So their previous experience with success in the class might keep them from giving up later, like they otherwise might, when they struggle with the harder stuff. So, like I said, that's an interesting application of what the research has found regarding learned helplessness and how to prevent it. Okay, well, that's going to do it for your video lectures for this week. Remember to get your weekly activity and your weekly quiz done and submitted in Canvas before the weekends on Sunday. You also have an exam this week, so you'll need to make sure that you take that exam before the weekends on Sunday too. There's also a study guide for that exam available in Canvas, so I'd encourage you to check that out if you haven't yet. And as always, if you have questions about anything, then please let me know. Okay, take care, guys.